Okay, we're going to start with the 10.7-3 notes, polar graphs for restricted domain. So what we're going to notice here is we're still graphing polar graphs. However, these ones are going to restrict our domain not from 0 to 2 pi, but rather maybe 0 to pi or pi to 2 pi. It's not going to be the full picture. The first important thing is to notice on this chart up here which ones have a full cycle of 2 pi, which is the majority of them, but there are 2 of them that just have a cycle of pi, which means that for the cosine and sine circles, it only takes pi to get all the way around one complete circle. We saw that yesterday as well. Same thing for the rows. If it has an odd petal, pi gives a full cycle. If it has even number of petals, a full cycle will be 2 pi. And we'll notice that as we go through it. For this first one, r equals 2, we know that that's a circle with radius 2. A full cycle of this, looking up at our chart, would be 2 pi. But they only want us to graph from 0 to pi. So this is only a half cycle, which means it'll be a half circle. All right? My question is, which half of the circle is it? In order to figure out which half of the circle is it, you want to pick points and graph the points to check. So you always want to do at least 3 points. Start point, middle point, and end point. And if you need more, you can plug in more. The starting point is just the starting point that they give you, which in this case is 0. Notice we're starting with theta equals 0. We're going to fill in r. The middle point would be halfway between 0 and pi, which is pi over 2. And my ending point would be at pi. When I go to work this out, it just is r equals 2. Theta doesn't matter. So for each of these, r is still going to equal 2. So I can fill in the 2's, and these are my 3 points. On your graph, you want to always make sure 2, 0 is my starting point. To label starting point, I always put an S. My middle point at pi over 2, we are at 2. So I also want to always be aware of direction. So I want to put arrows on my graph. In which direction am I going? My ending point, notice it's a soft parenthesis. So that ending point is going to be an open circle. And then I'm going to connect and draw my arrows. And I'm done. So for this one, it was the top half of the circle. For r equals negative 2, example number 2, again, it's going to still be a circle with radius of 2. And so the full cycle is still, according to our chart, going to be 2 pi, which means this is, again, a half cycle. But we're going to pick those 3 points to see which part of the half circle is it. So again, starting point, middle point, ending point. For this one, I'm still going to start at 0, pi over 2, and pi. But notice for all of these ones, r is negative 2. And so as I go through and go to graph these now, you should see where we end up. Starting point, 0 is my theta. My radius is over here, though, at negative 2. I'm starting over here on the left. My middle point, pi over 2, I'm down at negative 2. So pi over 2, negative 2 will be down here. My middle point, and then my ending point, and again, it'll still be an open circle, is at pi negative 2. So I'm actually over here to end. Let's look at what happens with the cosine circles. So notice this next one is a cosine circle. And if I look at my chart, a cosine circle has a full cycle of pi. So notice the restricted domain for this one. If r equals 4 cosine theta, I have a cosine circle, which means full cycle all the way around would be pi, so 0 to pi over 2, this is, again, half of my cycle, which means I'm going to have a half circle, but again, I'm not sure which half circle it is. So let's pick our points. Start, middle, end. I'll go 0. To start, my ending point this time is pi over 2. So halfway between those, for my middle point, would just be pi over 4. And now I plug those into my equation. These get a little more complicated. r equals 4 cosine of 0, r equals 4 cosine of pi over 4, r equals 4 cosine of pi over 2. And you can obviously figure these out. That's 4 times 1, which is just 4. For this one, it's 4 times root 2 over 2, which is 2 root 2, approximately 2.8-ish. And this would be 4 times 0, which is just 0. And again, you can take your time and figure those out later. Starting point, 4, 0. Middle point, pi over 2, 2.8. So notice I'm going in this direction, middle point there. And ending point, pi over 2, 0, open circle for that one for my ending. So it's the top half of that cosine circle that we would normally see. All right, let's look at number 4. Number 4 is now a cardioid. If you look at the chart on the previous page, a full cycle for the cardioid would be 2 pi, which again means this is half of my cycle. So I'm going to get half of the heart. My question is, which half of the heart? Top, bottom, left, right. Well, we won't know unless we pick our points. So again, let's go with start point, middle point, ending point. Starting with 0, middle point pi over 2, ending with pi. As I go through, plug it in. 3 plus 3 sine of 0. 3 plus 3 sine of pi over 2. 3 plus 3 sine of pi. As I work these out, and again, you can work this out, you know what these are. This should just give us 3, because that's 3 plus 0. This one should give us 3 plus 3 times 1, which is 6. And this one again gives us back to 3 plus 0, which is just 3. So I have 3, 6, 3 for my points. When I go to graph those, starting point is here at 3, 0. My middle point is up here at pi over 2, 1, 2, 3, 4, 5, 6. There's my middle point, so I'm coming up to there. And my ending point is down here at pi, and the r is 3, so I've come back down. If you picture this whole cardioid, you'd see that it would go right in here and back here if we kept going. So from 0 to pi we get to here, then if I kept going all the way to 2 pi I would complete the cardioid, but since I'm restricting my domain, I only want from theta being from 0 to pi. The next videos are going to continue with examples 5, 6, and 7. You can go to the next video.